I'm Brian Birtles. I'm with Mozilla, where I've been working on animation components in Firefox on and off for about 10 years now. Some people say that's because I'm really slow. I like to believe that it's because animations are just infinitely amazing and you never get bored of them. After all, with animations, we can make amazing artworks like this one, or everyone's favourite, this one. But actually the thing is, with animations, we can actually do more than just cat GIFs, it turns out. Animations is basically using time to convey information. So we can use animations for storytelling. This is a classic Japanese novel, Tale of Genji, much too long for normal people to read, but with animation we can get the story across a lot more easily. If a picture's worth 1,000 words, then an animation's probably worth about 6,000 words per second. So, 60,000 words per second, isn't it? We can also use animation for data visualization, especially for time-varying data. It's particularly useful. So this is a map showing all the tweets sent in and out of Japan just before and just after the earthquake just over 3 years ago. So you can describe that with text, or you can have a series of static images. But with an animation, it's much easier to convey that information. We can also use animations for interface design. This is the famous Genie effect on Mac. And using animation, it's really easy for the user to understand what they've just done when they've minimized that window. They know exactly where to look for it later as well. You don't need any extra prompts, which need to be localized. You don't need any extra icons, which take up screen real estate. You just convey the information really naturally. In Firefox as well, it's an old version of Firefox, but we have a similar thing for the download function. When you download the file, you know immediately where to look for it when it's finished downloading because of that animation. So animation is really great. When it's good, but when it's bad, it's really bad. It's horrible. This is the same animation running in 2 different browsers, and in this case, it's pretty painful to look at. Not only does it look amateurish, and not only is it frustrating to just kind of watch this jerk around on the screen, if you're using animation to convey information, then if you're dropping frames, you're actually losing information. If you're using, for example, animation for that download effect, and you see the first frame of the animation and the last one, then you've lost the effect completely. It's absolutely useless as a UI tool. So with animation, performance is actually really critical because time is what you're actually using as your medium to convey information. So there's lots of tips out there for how to make animations faster, but sometimes those tips don't work, or they only work in one browser, or they actually make things worse. And there's tools out there as well which can tell you when something's going slow, but they don't really help you work out how to make things fast. And so what I want to do today is talk about animation performance by explaining a bit about what a browser is doing behind the scenes. Because I think if you understand more of what the browser is doing, it's easier to reason about why something's slow and how to make it faster. The thing that prompted me to do this talk was I read an article about 6 months ago by the author of quite a well-known animation library, JavaScript library, and that author made some claims about animations which weren't actually quite correct. And I thought, if that person doesn't know, then I guess a lot of people don't really understand what the browser's doing. So that's the kind of journey I want to take today, is from the markup and script that you give to the browser to the point where it hits your eyeballs. And as we trace that journey, we'll look at how we can make each part of it faster or skips parts altogether so that we get smooth flowing animation delivering the effect that we intend it to. So this is the journey we're going to take. It might look a little bit busy at the moment, but walk through it stage by stage. The first stage is the parsing stage, and then we move on to the styles in blue, and finally to the graphics in green. And at each point we're looking for steps we can skip or steps which we can speed up so that we get from start to finish more quickly within hopefully 16 milliseconds, so we can keep the animation going at a rate that is acceptable. First of all, let's zoom in on this part, parsing. The first thing that happens when we load up a web page is we parse it into this kind of content tree here. That's all very complicated, and normally browsers do that on a separate thread if they can. just because it can be expensive. I'm not actually going to go into this too much. I had planned to, but in the interest of time, I'm going to kind of abbreviate this section because in terms of animation, there's not a whole lot we can improve in this area. Sometimes we can get a slight improvement by using different APIs so that we do less parsing, but for the most part, as we go further along that journey, the costs involved get bigger and bigger, and so the opportunities for making it faster get greater. So to give you the summary of how parsing influences animation, I did a little test where I was doing an SVG animation. In one case I used a set attribute call and did a micro benchmark to see how fast that was. In another case I used a type API where we don't do parsing. And you can see there's some significant performance improvements there, except for this last case of transform, I actually got worse. But if you actually put that into a real world animation, you won't see any difference at all. Actually, I'll show you that very briefly. So here's animation that's getting slower, using set attribute, change it to SVG DOM, it doesn't change at all. So it might be significant in a micro benchmark, but in a real world animation, parsing generally doesn't have a big effect. I could maybe see 3 frames per second difference when I profiled it. Not as significant as the other stuff we'll look at later. So that's one thing we could try, but I wouldn't bother too much about that. Let's move on to the next part, styles, and this is much more interesting. After the browser has built up this content tree of all the stuff in the document, the next thing it does typically is turn that into a representation that's more suitable for rendering. That's called a render tree. In Firefox they call that a frame tree. It's the same thing. And it basically looks something like this. This is what Firefox will do in this particular case. Browsers differ, but roughly the same. We have 2 inputs. We have the DOM tree, the content tree we parsed, and then we have style information as well. That style information we parse as well, and we stick it in some style structures. In Firefox, that's various tree structures. We take those 2 inputs and we perform the style resolution to create a frame tree or a render tree. And you can see there's a rough correspondence between the 2 trees. The biggest difference you might notice is that stuff that's marked display none in the content tree doesn't actually end up in the render tree. It's just factored out of the equation. And we can exploit that in our animations. For characters that are off stage, we can mark them as display none. Then they never enter the render tree and they're just out of the equation. And that can actually sometimes make a difference to performance. I'll run a little test here. So this animation, oh, it's going faster than usual. I don't know why that is. That's really unusual. That's good. Hopefully, this is going to totally destroy my talk if this goes more slowly, and it does. Normally what happens is this one on the left goes significantly slower. Oh, this one's actually going faster, so that's good. That proves the point. The difference between these 2 animations is in the first one we just keep moving these foxes up and up. In the second one we keep moving them up, but once they reach the top of that viewport there, we mark them as display none. Basically all that means is that it never enters the render tree from that point on. We don't have to worry about it for all the other operations like layout and so on that occur after that. So there's a marginal improvement there, but if we look at other browsers where I ran this test, you can see sometimes we get a massive difference there. The reason we don't get a bigger difference with Firefox is actually because for that particular case, Firefox wasn't doing layout to begin with, whereas the other browsers were. Come to layout in a second, but just one point to consider there when you're trying to optimize your animations is that sometimes we can get a real benefit by taking stuff that's off stage and marking it as display none. This is a little project I've been involved in from time to time. It's a tool where users can create SVG animations on their phone or whatever, and then they send them to this service, this server where they can bind in this kind of collective artwork. And it's quite computationally expensive to render this animation. But one way which we've been able to make it run a bit more smoothly is as these characters get off the side of the stage, we mark them display none, and that tends to free up some resources, even for SVG animation. That's not to say display none always fixes problems, but it's worth a try. Looking in a bit more detail at what happens in this style, resolution process, there's a few different operations we do. We match up CSS selectors, compute styles, and then we build up these frames. But then the second thing that happens, and this is the expensive part normally, is once we've got those frames, we have to work out where each of them is. We have some constraints, like maybe this frame should be such and such a width. But we don't have all the information specified. We don't know where each should be positioned on the page or how high they should be. And so that's done in a process called layout, or in Firefox we call it reflow. It goes through each frame, handles all those constraints, and gives each frame X and a Y point, a width and a height. And if the frame breaks across lines, then it does that as well, and splits up that frame into several frames for each line. So that can be quite expensive, and something which we may want to fix up in our animation. If we're doing a lot of that, our animation can go more slowly. So first of all, how do we know if that's actually slowing our animation down? Well, there are tools for that. On top is Firefox. That's the newly tidied up performance profiler, which you can just get to from the developer tools, which in all browsers now pretty much you press F12 and you get these developer tools come popping up. So that's Firefox's one, and you can see in the picture different items which represent those style and layout operations. In Chrome, it's even easier. You can see recalculate, style and layout are listed there for each frame, so you know how expensive that is. Firefox has one extra tool which is quite handy for that, and that's reflow logging. If you turn this on, then every time the browser does this reflow, it'll tell you in the console, and it'll tell you how long it took, and if it was forced by JavaScript, it'll tell you what bit of your JavaScript caused it as well. So let's try that out and see how different animations influence reflow. I've got this example here, and I'm just going to load up the dev tools and turn on reflow logging. So first of all, I'm going to animate the middle fox in each case, and the first one I'm going to use the margin left property. You see all these reflow events on every frame of the animation. It's doing that reflow process. If we clear the log and do an animate left on a position relative element, there's no reflows performed at all in Firefox. In some other browsers it may cause reflow. Same with absolute. And with transform as well. Transform shouldn't cause the browser to do this layout operation, because transform's defined as something that happens after you've laid out where things go. So just comparing how other browsers behave, from what I could observe, it seems like all browsers will do reflow if you're animating margin left, but not if you're animating left. In Firefox, if it's on a position relative or position absolute element, it looks like we've optimized that case more aggressively. But in all cases, if you animate transform, it shouldn't be triggering reflow, which should mean animations run more quickly. So let's try it out. Animating margin top here. Again, it's going really fast today. And if we try transform, yes, even faster. There's actually two reasons why transform is going more quickly in this case. One we'll come to in the graphics section. That's because it's actually layerizing these elements. But it's also avoiding layout. That's the important point here. So a few ideas to try in terms of making animations run more quickly with regards to how style works is we can try using things like transform, which don't trigger reflow, and things like color and opacity as well don't typically cause reflow. So they are typically faster to animate than something like margin left, which does. Finally, font size. Probably should avoid animating font size, especially at the root of the document, because that often is disastrous for performance. That causes everything to be recalculated. So if you're just trying to make something bigger so that it's easier to read, try scaling it instead. One other thing to be aware of, if you're writing animations from a script instead of, say, CSS or a smile animation, is that browsers don't do these operations unless they absolutely have to. They're basically really, really lazy because they know these are expensive, so they want to avoid them if they can.
It's kind of like with email. If you reply to email immediately, you end up writing more email than if you just keep putting it off, by which point you can ignore half of it. The browsers adopt the same strategy here. Basically, if you say change this style, it's going to go, that's great, I'll get to it later. And it's only actually going to get around to doing anything with that when either it has to paint or when you ask it a specific question about what is this style doing. So if you say to the browser, what's the computed color of this element, it's going to have to process those pending style changes so it can give you the right answer. And if you ask it about geometry, it's typically going to have to do layout as well, so it can give you the right answer to tell you where stuff is. And so that can be costly, and if you can avoid it, it's a good idea to do so. Basically, you don't want to write something like this, which is a loop that's going over all these elements, and it's reading the position, it's setting the position of one element, and it's reading the position of the last one, so it's triggering reflow over and over again within a loop. There's heaps of ways to rewrite that so you don't end up querying style all the time, and it's generally going to pick up improve performance significantly. Based on my tests, you see a massive difference for Chrome and IE. Only reason Firefox doesn't have a bigger difference is because I was using the top property, which, as we saw before, doesn't always trigger reflow. So that's another thing to try in terms of getting animations to run more smoothly. Scripted animations, just don't force the browser to do work it doesn't want to. Final section is graphics, and I was speaking to one of our graphics guys yesterday, and he said this diagram is not actually quite right. Most of this diagram is generic to most web browsers. This display list part is unique to Firefox from what I can tell. And basically, after we've got this render tree, there's all these frames filled out, we go and we build up a list of the things we need to paint, and then we knock out the bits we don't need to do, and we paint them. But actually, we first build up the layer tree, and then we paint into that. So it's not quite right, but it's close enough for the things I want to explain today. Amongst all of this, that paint step is normally the killer one. That's the really expensive one for most web pages. So that's the thing we really want to either speed up or just not do altogether. In terms of cost, it's pretty much a product of the area you're repainting, but also the complexity of the thing you're repainting. We can tell how much we're repainting using things like paint flashing in Firefox, which you need to turn on this button, but then you can see what's being repainted. And Chrome has a similar function as well, show paint rectangles. So I'll demonstrate that for you. And here it is here. This is the tool. If you don't see it, you need to go in here and turn it on. So then if I start this transition, every time it paints another coloured rectangle which shows you the region that was repainted. So you can see it's doing a lot of little paints along the way. If I compare the painting done with margin left versus transform, you see it's actually quite different. With transform, we basically paint once at the beginning, and then we don't paint again until the end. That's because for transform, we're putting it in a layer, which we'll come to in a second. So again, the choice of animated property can make a difference to how much painting is done. It's also interesting to compare between different browsers what they repaint, because they don't always do things the same way. This one here in Firefox, see it kind of does a more or less minimal repaint, but if you do the same test in Chrome, it seems to do the union of the two rectangles. And I'm told that that can mean if you're animating the top left and bottom right at the same time, the performance might not be so great. The other thing apart from the paint area to bear in mind is how complex the paint operation is. And typically some things like box shadow and border radius can be more expensive. And sometimes it seems a combination of the two is the most expensive. So sometimes a flat design might actually animate better as well. SVG filters are being hardware accelerated in a lot of browsers now, but still sometimes they may be expensive. And you can sometimes work around that by replacing them with some other kind of content which mimics the same effect. So for example, this one here, on the left it's animating the blur radius,
of a Gaussian blur. On the right, it's kind of mimicking that by just blurring an element and then scaling it up and down. And they're animating at the same rate here because they're running off the same refresh driver. But if you look at these animations independently, actually the one on the right goes significantly more smoothly. So there are things you can do to adjust your content to make it cheaper to paint, and that actually can improve performance significantly. Taking that to its extreme though, perhaps one of the simplest things to paint is a bitmap. So another strategy is just to pre-render stuff, especially complex artwork. And that can have a drastic effect on performance. Firefox was really bad in this one. But animating an iframe with SVG versus animating an image referring to a PNG, so there's a massive difference in performance there. And so that might seem like a bit of a cheat and like a bit of an admission of defeat that browsers just aren't good enough or whatever, but everyone does this in native apps, in desktop apps, in Flash. People pre-render assets, they're going to animate to be sure it's going to run smoothly. So that's something you can do, but people here probably like their vectors, their crisp, scalable lines. And so there is a middle ground here. If you refer to an SVG from an image tag instead of an iframe, there are more optimizations that the browser is able to do, and in Firefox we've particularly optimized this case. And you can see even in Chrome and IE as well, it's going to be faster, basically because you're saying this, this graphic is not going to change except for declarative animation. And so the browser is able to do different optimizations.
Do you know how SVG performs if it's embedded in CSS?
Well, potentially it's going to be the same code path.
Similar to the image, right?
That's right, yeah, it's more or less the same code path, and so yeah, it's able to buffer that. Whether that's been as heavily optimized, I'm not sure, but potentially, yeah, that the browser can make the same assumptions about that content not changing that it can't with the iframe. So that's another thing to try if you're animating SVGs around the place. Finally, hardware acceleration. This is a topic which I think Neil's going to tell us about tomorrow, but at least in Firefox, we're not doing hardware acceleration with parsing text. I think that's true of Chrome as well. Basically, the requirements for text on the web are very advanced, and the sort of text you get out of hardware is generally not sufficient for web page rendering, and parse to some extent. It's good enough for games, but not really for web pages. So that's something which we're not doing much yet, but is an area for investigation in the future. Filters are being hardware accelerated in a lot of browsers at each browser at different stages, but in the near-term future, I think it'll be the case that it'll be optimized across the board. But currently, it depends on the browser, it depends on the content, whether you get hardware acceleration for filters. And compositing is something which browsers definitely are using GPU for. And basically, the idea is here, as we heard a bit from Frank before in his talk, render a series of bitmaps as layers and then composite them on the GPU. And the reasons we do that is we can then move those layers around independently. We can transform them on the GPU, change their opacity, and then composite them on the GPU. And that's a lot faster than having to repaint the whole thing every time. If we're animating one of those layers, changing its position, for example, we don't have to repaint at all. We can just change the transform on it, and then we just recomposite after that. And that is, that's going to make the biggest difference to animation performance in a lot of cases. And it's tempting to think we should just make everything a layer, because then we get amazing performance for everything we never have to paint again. But it's not quite like that. Actually, layers come with a cost. First of all, in terms of memory, you've got this vertical stack of buffers, so you're multiplying the amount of memory you're using, but also setup costs as well. If we have too many layers, we end up actually going more slowly. So basically, that decision about what gets put in a layer, we leave to the browser, and the browser is generally best able to guess what's going to work out for us. Sometimes, though, we might want to give it a hint. But first of all, let's look at these layers. In Firefox, the sort of things we use layers for include animated transforms, like this one, or opacity animations, or 3D transforms, even static ones. We use layers for them. How do we know if we're getting layers or not? And in Firefox, you have to set a pref, and it's only going to work on platforms where we have off-main thread compositing turned on, which is basically everywhere except Windows. It's only in Nightly and Aurora. Probably land in release in 33. In Chrome, there's a button for that, show composited layer borders, and in Firefox OS as well, there's settings for that. And if we turn that on, I'll just do that here. Yeah. So if you turn that on, you can see this 3D transform's already got a green border around it, which says that that's in its own layer. If we animate the transform, it gets a green border, so it's got a layer. Same with opacity. If we go back to the transition I showed you before, it's probably a bit hard to see, but there should be a little green border around that transform right until the point where it finishes. That's why it's not actually repainting all along the way, because it's in its own layer and we're just moving that layer around, not actually repainting. And this applies, of course, to SVG as well. There's the smile animation, the London Eye, and yeah, you can see that that rotating part is in its own layer. And even scripted animations, it works as well. Basically, the browser sees, okay, you're moving that thing a lot, that probably deserves its own layer, and so automatically puts it in its own layer. In this case, it's got a red border. That's just because it's an image layer. That's just an implementation detail. It doesn't really matter. Sometimes, however, the browser doesn't have enough information to be able to make these decisions. So in this case, we've got a pinwheel animation. And as soon as we start animating it, the browser gives it its own layer. And that's fine for a desktop computer like this, which is pretty fast. There's no problems at all. But if we run this on a phone, for example, especially one which is busy doing other things, you might see a lag at the start of that animation because it takes time for the browser to set up that layer, to re-render that extra bitmap and pass it over to the GPU. So in that case, we want to actually give the browser some advance warning that you might want to put this in a layer. And we can do that with will change. That lets us tell the browser, we're likely to change this property soon, so do whatever optimizations you need to make that happen quickly. There's other properties we can say, like scroll position or contents, which let the browser do similar optimizations as it chooses. You might have seen people use transform and translate Z for this. Don't use that. It's browser specific. It only works in Chrome, maybe Safari. Doesn't work in Firefox, and it's not guaranteed to work in the future as well. And semantically, it's not very helpful. So will change works in Chrome, I think, from 36 or something. And it's implemented in Firefox, but prefed off at the moment. So should prefer will change for that. If we apply it here, you can see that immediately this thing gets a layer as soon as we turn will change on. So that means it's ready to animate as soon as we trigger it. So we can do this kind of effect and be sure that these things are not going to stutter and start at the beginning. The last thing I want to talk about is jank. Animation is not just about sheer number of frames you can get out per second, but it's also about having a consistent frame rate. And when you have animations in web pages, often you see this sort of effect where they stutter all over the place. And the reason for that is that the code that's running the animation is running in the same thread as all the code that's processing events, that's doing layout, that's doing garbage collection, and a million other things. And so when those things occur, the animation gets starved and it janks around like that. And so one way we can try to fix that is we can actually offload that animation to a separate thread called the compositor thread. It looks something like this. Basically, we work out all the parameters for the animation, pass it off to another thread, and that just ticks away happily, regardless of how busy that main thread is. So here we are, animating the script, and if we perform a busy operation, it kind of stops and starts. With CSS, we know the parameters of the animation, so we can pass it off to the compositor, and then it doesn't stop and start. It just keeps going, even when we try to interrupt it. There's a few kind of caveats to be aware of there, though. Not everything can be animated in this way, only stuff which we can really do on the compositor. So basically transform and opacity. That's true for Firefox and Chrome, but hopefully, and I think IE as well, but I expect in the future that set will expand. It's not available on every platform. For Firefox, we only have it switched on for Firefox OS at the moment, but we'll probably switch it on other platforms soon. And there can be all sorts of other limitations. Like I think in Firefox, if you animate top and left at the same time as transform, it might not be eligible for running on the compositor. That's a bit unfortunate that it's so kind of opaque what gets run in this way, but we're working on dev tools to expose that information so you can see when stuff is being run on the compositor. Perhaps the biggest drawback though is this only really works when the browser knows all the parameters of the animation. So it doesn't work for scripted animation because the browser doesn't know exactly how you're going to animate things in advance. So currently we've only got it turned on for CSS animations and transitions, but it could be done for SVG for small animations too. So if you want to write animations with script and still get this kind of performance, then one possibility is something I've been involved in with, which is called the Web Animations API. That's basically an API into the browser's animation features. So you can declare the parameters up front and then give it to the browser to animate, and it can optimize it in all sorts of ways, some of which script can't do. So this subset of the API is already available in Chrome 36. And we're working on a different subset in Firefox. Parts of that's already in Firefox. And then we'll come to this part later in the near future. If you just want to use an API though and have it be really fast when it gets implemented natively, there's a polyfill for it as well, the original polyfill and the new shiny version, which I think is nearly ready. So that's the end of the journey today. We started off looking at parsing, and we saw how using different APIs can give you a marginal performance improvement sometimes. Went to styles, and we could see that characters off stage, if you make them display none, can sometimes speed things up. And also that by using the right kind of properties, we can avoid reflow and the cost that it brings, layout that is. With regards to graphics, we saw how we can try to make the paint cost cheaper by using different effects or by pre-rendering or even using image element, and how using transform and opacity means we can actually put that element in a layer and animate just the layer, and using will change to make sure that layer is ready in time. And then finally, by using declarative animation or this animation API, we can actually set up the animation so that the browser can delegate it to another process and run it smoothly regardless of how busy the browser is with other tasks. And hopefully if we do all that sort of thing, our animations will run smoothly regardless of the browser, regardless of the device, and will convey the effect which we designed them to convey. So I hope that's been useful to you. If you're interested in that API in particular, that's something I'm quite involved with, so I'll be happy to talk about that. That's the spec there, or else feel free to contact me if you have questions about any of that. So thank you very much.
So there's no mic in this room for questions, so you just have to project your voice. Who's up first? Cyril.
So using display none versus using visibility hidden.
Yep.
Initially, in my animations, I was using display none, and I've been told that it's bad and I should use visibility hidden. Now you say I should use display none.
Yep.
What's going on?
It depends on what you're doing. If you're doing a frame-based animation, you'll generally be faster off with visibility, because then you're not putting stuff in and out of the tree and triggering reflow all the time. If something's off the stage for a long time, you generally be better off with display none. But you have to profile your specific application and see what it's doing to know which is going to give you the better results. But generally, that's the way I would think. Frame-based stuff, visibility hidden. For stuff which is off stage for a long time, display none.
Yeah, I'm not going to complain about how all this came to be, because I know that it's a mess and you're all engineers who are trying to fix it as well as possible. I only have this complaint about CSS is so expressive we can do lots of things, but then we cannot use it with performance because we have to resort to pre-rendered parts of the image, not use borders, not use shadows, not use the shadow property. Is there any initiative so we can say, okay, we have this block, it's created with CSS, it's got shadows, it's got gradients, it's awesome. Freeze it. Tell the browser, do it yourself, and then just compose it on thread instead of us having to say, no, designers, can you do this image with this border, this shadow, you know? Is there some idea trying to do that? So we can freeze a block of and just let it run in animations?
So you want to like rasterize it once and just keep using that buffer, is that?
Yeah, it would be like the opposite of will change, like this structure won't change.
Oh, will not change.
You could always do it yourself because you could rasterize a lot of stuff in Canvas. So if you really want to.
Yeah, but that's my point.
No,
We shouldn't be doing it. It's like there's all this framework with CSS that we don't just tell the browser. I mean, the browser's already doing it. It's like just keep it. Keep this context and use it.
Gee, I don't know.
Well, what are you going to do with it? Are you then going to transform it? Or?
I'm not going to do anything. It's just a matter of the browser knowing that this is going to stay like it is. So it could use all the functions, all the SVG filters, all the CSS filters, all the drop shadows, just render it and use it. So we don't have to do it in Canvas or with Photoshop or something.
So if you've got will change transform on it, then it can actually like that. Because it anticipates.
But will it like cache all the subtree
Yes.
leaves? Yes.
Same for translate Z and WebKit and Blink.
Yeah.
Same for translate Z and WebKit and Blink.
Yeah.
Good radios.
I guess it's confusing that it's will change transform, but you don't actually want to change transform. So it's the same kind of optimization that the browser is going to do that would be helpful if you were to translate it around the screen.
No, it's good. I mean, will promote the layer to be composite, so that's cool. Cool.
How's the server project coming on? Do you ever see that replacing the main Gecko engine? And how will that change along 47?
Yeah, I really don't know about performance. It is progressing. I know people who are working on features, and I think it passes ACID 2 now. So it is progressing. I have no idea when we could realistically substitute, that for Gecko. But
I think it might be the next 2 years.
well, that'd be great. Yeah, I don't know. Does anyone else from Mozilla have any idea?
I mean, I think it's still firmly a research project. So there is no fixed timeline for turning it into.
But is the eventual aim to become replacement? Because obviously it's built in a language only to remain, and there's a lot, it's much more optimised.
I mean that's why the project partly exists, with the hope that we would be able to do that. But it's not. We've not nailed down that it is actually going to work. That's what purpose of a research project. You're examining the issues, seeing which ones can be solved, seeing which ones can't be.
Yeah. Recently, it seems to be coming along. Yeah. So, yeah, I hope one day, but I don't know when that will be. Yeah.
Any more questions?
Can I have one? All the examples you showed of animations were more related to user interface animations, rather than storytelling.
Yeah.
In the sense that in storytelling, usually you have some requirements for synchronized animations or frame accurate synchronization. Of the 3 methods you demonstrated, is there one that is considered better for frame accurate synchronization than the others?
It's potentially to frame accurate, I'm not sure. In terms of keeping things lined up, it's possible to do that with all 3, scripted, Smile or CSS. Although when you start running stuff on the compositor, sometimes they can drift a bit.
For instance, when you can interrupt the main script that does the animation, then you're stuck. You won't have synchronized animations. So
right. They'll still line up in position once the main thread catches up.
Yes.
But you will have some frames where one component perhaps is moving and others not. Yep.
And CSS, is it going in the direction that where there would be synchronized animations? Or?
It's possible to do some very limited synchronization at the moment, but yeah, we want to add features to make that easier so you don't have to rearrange a document just to produce the synchronization you need. Yeah, that's something which definitely want to do soon.
Thanks, Brian.
Thank you.